All right, welcome. In this video, we're going to start a new unit over rational functions. We're going to start by talking about some rational equations. But before we begin, I think I probably need to tell you what I mean by rational. So a rational function is kind of like a rational number, right? We've talked about rational numbers in this class. A rational number is a fraction. It can be written as a ratio of two integers. Well, a rational function can be written as the ratio of two polynomials. Okay, and a rational expression is some kind of fraction like these things that we're going to be simplifying down here. Okay. The thing that we have to do for Texas Algebra 2 is we have to determine the sum, difference, product, and quotient of rational expressions with integer exponents degree 1 and degree 2. Now, we might do a little bit of degree 3 just to practice our group and factor, but mainly thinking about degree 1 and degree 2. So let's start by, what do we mean by simplify a rational expression? We're going to start off with something pretty basic like this 3x divided by 4x. What we're going to do eventually is just kind of cross off the x's and be like, okay, this is equal to 3/4. But to remind you of why that's true, remember that we can like multiply two fractions by, just multiplying straight across. Multiplying the numerators, multiplying the denominators. So I can say that this 3x over 4x is 3/4 times x over x. And then this x over x here, well, that's always going to be equal to 1 because y'all know anything divided by itself is going to be 1. Now, I'm going to point out that that is true as long as that thing divided by itself is not 0. 0 over 0, not defined. We can't divide by 0. We've never been able to. We're not going to be able to in this class. So what I'm going to say is this is like 3/4 times 1, and multiplying by 1 doesn't do anything. So this is equal to 3/4 as long as x is not equal to 0. Now, in this Algebra 2 class, I'm not going to be as concerned with the disclaimer of what x can't equal as much as I'm concerned with you getting from here to there. Okay? Save that discussion for a different day. And then I'm going to do this next one for you, and I'll leave. Maybe I'll do the next two. Okay, so 3 times 4 times x. Okay, well, we can, I've told you before that like 3 times 4 times 5 is the same as 5 times 4 times 3. And we can multiply things in whatever order we like. So what I might do is I might grab that 4 and deal with it first. Then I've got a 3 on top and a 2 on bottom. And then I've got an x and an x. Okay, 4 over 4, that's 1. X over x, that's going to be 1 as long as x is not equal to 0. So this is going to be equal to 3/2 as long as x is not equal to 0. I think, this one, no, there was value in this example. Okay, I almost made the same mistake in class during the lesson. It's like, this is basic. We don't need it. We've done it twice. But sometimes I forget. If we're going to, cancel off these x's, kind of the question is, what am I left with on top? Am I left with a 1 or am I left with a 0? So what I'm going to say is x is like 1 times x, right? And so if I have 1/3 times x over x, that's going to equal 1/3, not 0 divided by 3. And I suppose this is true as long as x is not equal to 0. Okay, but let's do some more that are maybe slightly more interesting. All right, this is kind of more in the wheelhouse of what we're going to be working with in this class, this unit. Going to be, kind of a ratio of two quadratics so we can practice our factoring, we can do some canceling, some simplifying, and then eventually we'll be interested in graphing things that are, I don't know about this one exactly, but depending on how it simplifies, this might be the type of thing we're interested in graphing in this class. Okay, so first, the common factors here, and so I can rearrange them so that I'm multiplying by x minus 4 over x minus 4. And then I can say, I'm actually multiplying by 1, so this is equal to x plus 5 over x plus 3. But I don't expect that you'll be doing this forever, right? You'll know that if things are multiplied together, we can, if they're connected with multiplication, it's eligible for canceling. Okay, and if I see the identical factor on top and bottom, I can just cross them out because I know that that's like a 1 over here in parentheses. Okay, but this is going to be true as long as we're not dividing by 0 in the original expression. Now, I've kind of written on the original expression, but the original expression was undefined where x is equal to 4, right? Because it causes division by 0 right there. So as long as x is not equal to 4, this equality is true. Now this next one, we're going to have to do the factoring work ourselves. But that's going to be very typical in this class. You're going to be expected to do a lot of factoring in this unit. So I'm going to be thinking of two numbers that multiply to -3 while adding to -2. And to me, that's feeling like -3 and +1. So that's going to be x minus 3 times x plus 1 divided by, okay, two numbers that multiply to 4 and add to 5. I'm thinking +4, +1. So x plus 4, x plus 1. And then at this point, I see that x plus 1 on top and bottom, and I'm going to cross them out, and I'm going to say, all right, this is equal to x minus 3 over x plus 4, just as long as the thing I crossed out is not equal to 0. Okay, so as long as x plus 1 isn't 0, as long as x is not equal to -1. But I think that's all I'm going to say about the, canceling on top and bottom thing. Let's move forward to where we're actually going and, I'm going to do one with division because it's been a while since we've done that. But then I'm going to move on to adding and subtracting. Yes, I like this one because this is fraction divided by fraction. Okay, so this is going back to something you learned about a long time ago, that if you're dividing two fractions, you're going to leave the first one the same, you're going to flip the second one, and you're going to turn it into multiplication, because division is like multiplication by a reciprocal. So what I'm going to do, I might actually factor this first before starting to rewrite it with multiplication, because that'll make our job a little easier. So I'm going to factor the 10 out of the 10x minus 40. So I'll have 10 times x minus 4. And I'm going to just scratch that so I'm not distracted by it. X squared minus 6x plus 8, that feels like x minus 4, x minus 2, yes. Okay, so x minus 4, x minus 2. Okay. X plus 3, there's not anything I can do with x plus 3, but 5x plus 15, this can be factored. Okay, I'm going to factor out the 5, and I'll be left with an x plus 3. And if you want to cancel this stuff off before, rewriting as multiplication, you can do that. That's fine. I'm just not going to do that. So 10 times x minus 4 over x minus 4. Okay, times the reciprocal. So it's going to be times 5 times x plus 3 divided by the numerator x plus 3. And now since I've got these identical factors that are connected with multiplication on opposite sides of the fraction, I can cross them out. And I'm going to be left with 10 times 5, which is equal to 50, just provided that we weren't ever dividing by 0 in the first place. Wait, hold on, I lost something. That's going to be 50 over x minus 2, pardon me. I lost that x minus 2 there. And so I just don't have any choice but to put it there. And I'll have 50 over x minus 2. Yeah, that seems more like what I got in class. All right, now let's do some addition and subtraction. So I think what I want to do is go all the way back, right, to those elementary school arithmetic principles that I was talking about earlier. If we're multiplying two fractions, we multiply straight across. And if we're adding two fractions or subtracting two fractions, they have to have a common denominator. So that something like 4/3 plus 7/3, well, we could just add this together in terms of the number of thirds, and I would have 11 total thirds, okay, because they have a common denominator. Okay. And then, but something like 2/3 plus 3/4, which is kind of the next example in your book, 2/3 plus 3/4, is not something that I'm going to be able to add with it being written the way it is. I need a common denominator. And in general, a foolproof way to find a common denominator is to just multiply the two denominators. Now, sometimes if they have a common factor, there'd be some redundancy there, and you'll have to simplify at the end. But I'm generally just going to multiply by the opposite denominator and even when there's x's involved. So 2/3, I need to make this a denominator of 12. So I'm going to need to multiply by 4 in the denominator. But I can't be changing the value of 2/3, otherwise I wouldn't be able to accurately find what 2/3 plus 3/4 is. So I need to be multiplying 2/3 by 1, and that's where I'm multiplying by 4/4 there. Okay, so that's still 2/3 plus 3/4. I'm going to need to turn that into 12ths. So I'm going to need to do that by multiplying by 3 in the denominator. And to be fair to this fraction and not change its value, I have to multiply by 3 in the numerator as well. So I'm multiplying by a 1. Okay, so this is 2 times 4 is 8, divided by 3 times 4 is 12. Remember, we just multiply across when we're multiplying fractions. plus 3 times 3 is 9, divided by 4 times 3 is 12. And now I've got a common denominator, and I can add those freely. 8 twelfths plus 9 twelfths is going to be a total of 17 twelfths. And that's how we're going to add and subtract fractions. But let's do this with some x. I like this one. 4 over 9x minus 5 over 3. Because this is what I was talking about before when I said, there could be a common factor. Okay, so, 9x, if you broke it all the way down, it could be looked at as a 3 times an x, and I already have the 1 3 here. But I'm going to just approach this like I was saying. I'm just going to multiply by the opposite denominator on top and bottom and show you that this will always work, but that if you see this coming with some sort of redundancy, there's a way you can kind of work around having to simplify at the end. So 4 over 9x, I'm going to multiply by the opposite denominator on top and bottom, 3 over 3. Okay, and then I'm going to subtract 5/3 multiplied by 9x over 9x. Okay. And then this is going to equal 4 times 3 is 12, divided by 9 times 3 is 27 times x, minus 5 times 9 is 45x, divided by 27x. Okay. And then I go to combine these, 12 minus 45x. I don't really think there's any way I can combine those, so I'm just going to say, all right, 12 minus 45x divided by this 27x. But the thing is, because 3 and 9 had that common factor, there's going to be this redundancy here. I can factor a 3 out of top and bottom. And I will need to do that if I want my answer to be fully simplified. So it would be 3 times 4 minus 15x divided by 3 times 9x, and then I can cancel off the 3's. Okay, and I'd be left with 4 minus 15x over 9x. Okay. And that's how we're going to, add and subtract things with an x in them. Now, I'm going to really quickly, I'm going to just copy in the work. So I can do this a little bit faster by seeing what's coming, saying, okay, I can just take 3 and multiply it by 3x to get 9x, and so I'm going to leave this one the same, and I'm going to just multiply this one on top and bottom by 3x, and then I would get this 4 over 9x minus 15 over 9x, which combines to give you the right answer a little faster. Okay, but I don't really care how long it takes you or what road you take. I just want you to be able to reliably simplify these objects, and either way will work. All right, now here's one where we can just kind of ramp up the difficulty a little bit. So I've got 7 over x minus 3 over x plus 2. And these are not a common denominator, and unfortunately I can't just add a plus 2 to the denominator and the numerator of 7 over x. That would not be fair. That would not be, keeping the thing the same. I'll let you think about why that's true. But what I'm going to do is I'm going to go for a common denominator of x times x plus 2. So I've got 7 over x, and I'm going to need to multiply that by x plus 2. I'm going to put these in parentheses to remind myself that I'm going to need to distribute 7 over the x and the plus 2. Moreover, I'm going to need to distribute this x over that x and the plus 2. Okay, but then I'm subtracting 3 over x plus, and that's missing that x, so I need to multiply by x over x. Okay, and I'm over here, and I'm going to distribute. 7 times x is 7x. 7 times 2 is 14. Divided by x times x plus 2 times x. And then I'm going to subtract 3x divided by that same denominator, x squared plus 2x. And now if I've got these two things, I'm subtracting them. I'm going to have 7x plus 14 minus 3x. Okay, so I'd lose 3 of those x's. And I'd be left with 4x plus 14 over x squared plus 2x. Now, occasionally you will combine these things, and there will be something a little bit more that we can do to simplify. But that would be if we could factor the numerator. We could factor a 2 out, but then I'm left with a 2x plus 7. We're not going to be able to get a 2x plus 7 there. Nor am I going to be able to factor a 2 out of both of these things. So this is as far as I can go. And the last example I've got for you of something we need to simplify is going to be kind of like the fully actualized version. I've got x's all over the place on top and bottom of both fractions. So I've got x minus 1 over x squared plus 3x plus 2 plus x over x plus 1. Now I'm going to need to get a common denominator. But because, I can see that there's going to be a common factor between this denominator and that denominator, I'm going to suggest we factor this denominator first. So I'm going to say, okay, x squared plus 3x plus 2. What are two numbers that multiply to 2 and add to 3? 2 and 1. So I'm going to say x plus 2 times x plus 1 is this denominator. Well, I already have this x plus 1. Okay. So all I'm going to need to do is work on this one to get that same denominator, probably by multiplying on top and bottom by x plus 2. Okay. And then I'm going to say, all right, well, you know, I've got plenty of room down here, so I'm going to call this x minus 1 over our common denominator of x plus 2, x plus 1. And I'm going to add in, after I've distributed this x over the x and the plus 2, so that's plus x squared plus 2x, divide by x plus 1 and x plus 2. Okay. And then I'm going to combine these. And so, okay, if I'm adding these together, I'll have an x squared plus 2x plus another x. So that'll be x squared plus 3x. And the only constant I have is this minus 1. That's not going to be factorable because there's no two numbers that multiply to negative 1 and add to 3. Okay, I think in my class you're just fine to leave it that way. But if you don't like the denominator being factored and the numerator not being factored, we could just unfactor it, right, by doing FOIL, or just by going and looking at what we had before. It would probably be smarter. So x squared plus 3x minus 1 over x squared plus 3x plus 2. And you know, I think this is the perfect example for me to end on, because I try to avoid even suggesting it as a possibility because I don't want anybody to get the wrong message. You know, a really common error when first working this type of stuff is wanting to cancel too many things, wanting to really cherry pick, you know, or canceling. And it's too good to be true, right? I can't just like cancel off these x squareds and these 3x's and be left with negative 1/2. This is only true. I'm pretty sure this fraction is only equal to negative 1/2 when x is equal to 0. But if x is equal to 1, you can say it's okay, 1 plus 3 is 4, minus 1 is 3, divided by 4 and 2 is 6. It's not the same as negative 1/2, right? So it's positive 1/2, I think. And so we can't be canceling like that. There's nothing else we can do here unless we are able to factor the top and bottom and have an identical factor. We can only cancel identical factors. So that's all I got to tell you in this video. In the next video, I'll show you how to solve these rational equations. But that's all for now. Thanks for watching.